So these next few problems are applications problems. What I've decided to do is I've gone ahead and written all of the work for these problems just to save a little bit of time. And what I'm going to do is I'll just comment on the problems as we go through them. But if you want to slow things down, then I'd recommend just reading over these problems and seeing the work before viewing the video. So in this first one, we have this company's manufacturing mountain bikes, and we're given their marginal cost function. So we know the derivative here, and we want to know the increase in cost from going from 300 bikes per month to 900 bikes per month. So, and this is the cost function per month. So we want the change from a production level of 300 to a production level of 900 in the costs. So that would be the difference between the cost at 900 and the cost at 300. Now we know that that difference can be computed based on the fundamental theorem of calculus as the integral of C prime. Because remember, if you integrate C prime, then what you'll get is C. So if you integrate C prime from 300 to 900, then the fundamental theorem of calculus says that you'll get C evaluated at 900 minus C evaluated at 300, which is what we want. So we're going to be integrating C prime, which is this. If you first compute the antiderivative, it would be 500x minus x squared over 6. And by the way, this 6 is appearing because we originally had a denominator of 3, and then whenever we promote the power from a 1 to a 2, we should be dividing by the new power. So we would be dividing by a 3 and also by a 2. So that gets us a final power of 6. So that's what we get whenever we take the antiderivative, and then we just have the evaluation step. I just took this and plugged it into a calculator, and I got 180,000. So the difference in cost here would be 180 grand. Next, there's this little section over finding the average value of a continuous function. I've written the picture of what's going on over here. So if you have a function f, which is graphed in blue here, and you want its average value between a and b, that would be given by the height of this red line here. I'm going to denote that by f bar. That's just the average value for f on that little region. And to compute that average value, you just need to use this formula. It's basically the area divided by the width that we have for that region. So that would be 1 over b minus a times the definite integral that we've been talking about. So if you want the average value of this function from 0 to 4, then your a value would be 0 and your b value would be 4. So I'm just going to plug in those a and b values into the formula that we have up at the top of the page here. So this one's pretty straightforward. It's just about remembering when to apply this formula. You'll apply this formula anytime you want the average value of a function. So I'm not going to comment too much about these. These are both basic antiderivatives, and then you evaluate at the corresponding endpoints. So these are not super complicated. They're just basic applications of this formula up at the top. But I'd advise you to read over them if you need some more practice with them. And then lastly for this video, I want to talk about problem 12. In problem 12, we're given the total cost for producing X dictionaries is given by this cost function. And the point here is just to distinguish between the average cost function and the average value of a particular function. So remember, we defined the average cost function to be this thing over here. So we know that the average cost function is the cost function divided by x, where x is the number of units that you make. So if you want the average cost per unit, that would be you plug in 1,000 units into the average cost function. So you would have the cost for 1,000 units in your numerator and then 1,000 units in your denominator. If you do that evaluation, then what you'll get is 30,000 divided by 1,000, which ends up giving you $30 per unit. So notice that the units here are dollars per unit. So that's a little bit different from asking for the average value of the cost function on a particular interval. If we want the average value for the cost function, then we would be using the formula that was introduced on the previous page because we want the average value of a function. And if you apply that formula, you would be integrating the cost function. When you integrate it, you should get this, and then you would evaluate at the two endpoints. If you plug in 1,000, then you get this. If you plug in 0 into this antiderivative, you just get 0. And then the expression that you get at the end simplifies to 25 grand. So notice these are very different. The average value of the cost function will be some amount of money. In this case, the average value for the cost function was this 25 grand. The average cost per unit will end up being some number of dollars per unit that you make. And in this case, it's $30 per unit in Part A. So you can read over those examples more carefully if you'd like to. I didn't want to spend too much time on them because we've already done several examples involving this definite integration so far today, and I didn't want to take too much time for the videos, but read over them if you want some more practice rather with word problems.